Hello, everybody, and welcome to this Unit 14 lesson on 3D geometry. So in Units 12 and 13, we were talking about two-dimensional geometry. So we were working with flat shapes. In this unit, Unit 14, we are going to be focusing on three-dimensional shapes, so shapes that are not flat. And we're going to be talking about two really important concepts on the GED test. We're going to be talking about volume and surface area. So for this lesson, you definitely want to have your pencil and paper handy. You definitely want to have your welcome packet with you because we are going to be using the GED math formula sheet a lot. So either you can use the formula sheet that's in your welcome packet, or you can pull up a copy of it online, or if you just have a separate copy, you can use that. And you'll also be using a calculator today. The calculator on your phone will be fine. We're just going to be working with some bigger numbers and some decimals, so it'll make those calculations faster. So let's get started by talking about our learning goals for this unit. We are going to identify 3D figures. We're going to use the GED math formula sheet to solve problems. We're going to calculate the volume and surface area of these shapes: rectangular prisms, right prisms, cylinders, pyramids, cones, and spheres. So these are the shapes that are listed in the surface area and volume section on your formula sheet. So these are the three-dimensional shapes that you might encounter on the GED test. These are the three-dimensional shapes that you are given formulas for. And so we're going to work through all of these shapes today. And then we're also going to practice solving for missing measurements, things like side lengths, height, radius, diameter, when given volume or surface area. So we did something similar in units 12 and 13, where we were given the perimeter or the area, and we had to kind of work backwards to solve for a missing side length or missing radius, if something like that. So we're going to be continuing with those types of problems this week. Let's get started. First thing we're going to do is we're going to practice identifying these different types of shapes. So I'm going to start with, I think, probably one of the more common ones, and one that you've definitely seen before. It is this shape right here. So this is a box, otherwise known as a rectangular prism. Now you might have a rectangular prism somewhere in your house right now, somewhere nearby. If you have a shoe box or a cereal box nearby, then you have a rectangular prism sitting near you. So a rectangular prism is composed of 6 rectangles. So a top and a bottom, a front and a back, and 2 sides. So a rectangular prism has 6 faces, we call those. So faces are a flat surface on a shape. It has 6 faces, and all of those faces are rectangles. A cube is a special type of rectangular prism. So a cube is what we have when all of the faces are squares. So you might have a cube nearby, you might not. If you've ever seen like a Rubik's Cube, right, that's a rectangular prism. Sometimes tissue boxes are cubes. All of the sides are squares. So that's a rectangular prism. If you look on your formula sheet, you will see that you have a couple of formulas there for rectangular prisms. Next shape I want to talk about here is this one. Again, this is also a shape that you probably have somewhere in your house. This is a cylinder. So if you have a can of anything in your house, can of soda, a can of beans, then you probably have a cylinder in your house. A cylinder is 2 circles connected by a tube. The next shape I want to talk about is this one here. So this is just an example of a more general category of shapes called right prisms. So this is a right prism. A right prism is when you basically have two of the same shapes connected by a tube. So this one that I have on the screen here is two triangles connected by a tube. A cylinder is also an example of a right prism. With a cylinder, the two shapes we have are circles and then connected by a tube. And then a rectangular prism is also an example of a right prism. You could think of it as two rectangles or two squares connected by a tube. So a right prism is a more general kind of shape. And if you look on your formula sheet, you'll see you have formulas for right prisms. We'll see that those formulas are a little bit more general and they can be applied to rectangular prisms and cylinders, and also something like a triangular prism like I have here as an example. All right, next thing let's talk about, let's do the shape here. So what kind of a shape is this? This is a pyramid. And specifically, it's a square pyramid. All of the pyramids that you encounter on the GED math test should be square pyramids. That means the bottom or the base of the pyramid is a square. Pyramids can have lots of different shapes on the bottom. It could be a rectangle, it could be a triangle, it could be a hexagon. You can really have any shape at the bottom of a pyramid, except for a circle. But any pyramid that you see on the GED test will be a square pyramid, meaning all four of those sides at the bottom are the same because it's a square. So a square pyramid is where we have a square on the bottom, and then along each side of the square, there are triangles coming up to a point at the top. And then kind of similar to a pyramid is what we have over here, a cone. This is a kind of similar idea where we have a shape on the bottom, a circle, and then going up along the sides, those sides come to a point at the top. So this is a cone. You've all seen cones before. You know what a cone is. And then the last shape we have on here is a sphere. So a sphere is sort of the three-dimensional version of a circle. It's like a ball. So if you have a basketball or a soccer ball or any kind of ball in your house or nearby, then that's a sphere, as long as it's not deflated. Okay, so next let's do a little bit of review. Let's review the meanings of perimeter and area, because those are things that we got a lot of practice with in units 12 and 13. Those are really important concepts that come up a lot on the GED test, specifically when we're talking about our two-dimensional shapes or our flat shapes. So what is perimeter? When we're talking about the perimeter of a shape, what does that mean? Well, perimeter, one way you can say it is you could say it's the distance around the outside or the edges of a shape. Outside of a plane figure or a flat shape, a two-dimensional shape. So perimeter is about the distance around the outside of the shape. What about area? Well, area is about the inside. So area is the amount of space inside or covered by a two-dimensional shape, a flat shape. An area is measured in square units. So perimeter is a distance or a length that's measured in things like feet or yards, inches, meters, those distance kinds of measurements. Area, since it's different from distance, area is measured in square units. So things like square feet or square yards. And let's give ourselves a little reminder of how that works. So let's say I have a rectangle. got this little rectangle here, and let's say it is 2 inches by 4 inches. So if I split this rectangle into 2 inches along the side here, and then I split it into 4 inches, what do I have on the inside of my rectangle? On the inside of my rectangle, I have 8 square inches, right? I have filled my rectangle with little squares that are each an inch on all sides. So there are 8 square inches. So when we talk about these square units, we are literally talking about little squares that we're filling the shape up with. Okay. Next, let's talk about volume. So like I said, we're going to be getting a lot of practice with calculating volume and using volume today. So we need to know what it is. So volume is kind of the 3-dimensional version of area. So volume is the amount of space inside of a 3-dimensional shape. And volume is measured in cubic units. So if you take a 3-dimensional shape like a cylinder or a box, a rectangular prism, volume is how much space is inside. So how much stuff would it take to fill up that container or that shape? So why is it measured in cubic units? Where does that cubicness come from? Well, this is going to be a little bit trickier for me to draw, but I'll give it a try. So let's take that same rectangle, but I'm going to make it 3-dimensional. So now instead of just a flat rectangle, it's a box or a rectangular prism. So let's say this is still 2 inches and 4 inches. And let's make it 2 inches deep as well. So I'm going to go ahead and split this rectangular prism up now. So it's 2 inches this way. So I'm going to, it's like taking a knife and slicing it through the middle here. I just sliced, let's say this is like a stick of butter, right? I just sliced it through the middle there. And then it's 2 inches deep. So I'm also going to slice it this way. And then it's 4 inches long. So I'm going to slice it up into 4 inches along the length. So what have I just done? I have created inside of this stick of butter or this rectangular prism, I have created 16 cubic inches. I have created 16 little cubes that are all an inch along their edges. So when we talk about cubic units, we are literally talking about little cubes that we're filling the object up with. Okay, and finally, let's talk about surface area. So surface area is, it's a type of area. Surface area is the sum of the areas of all of the faces of a 3-dimensional shape. So if you take something like a rectangular prism, a box, it would be the total of all the areas of the rectangles that that box is made up of, right? So a rectangular prism is made up of 6 rectangles. The surface area would be the area of all 6 of those rectangles added together. So how can we say that? Let's say the surface area is the total area of all faces of a 3D shape. And since it's area, it's also measured in square units. So for surface area, if you know how to find the area of a flat shape, then you know how to find the surface area of a 3D shape, because it's just a matter of finding the areas of the individual shapes and adding them up. We're also going to see that we have some nice, neat little formulas to help us with those calculations. Okay, so let's get started with rectangular prisms. We're going to start by talking about volume. So if you take a look at your GED math formula sheet, a formula for volume of a rectangular prism, it says LWH. So that's length times width times height. So in order to calculate the volume of a rectangular prism, you multiply the length by the width by the height. So for this rectangular prism on the screen, I'm going to go ahead and give us some measurements to work with. So for this particular box, the length is 10, the width is 4, and the height is 5 inches. So I'm going to calculate the volume. The volume is going to be 10 inches times 4 inches times 5 inches. Now I want you to notice here that it doesn't really matter what you call the length, what you call the width, and what you call the height. As long as you are multiplying those three measurements together in some order, you will get the volume, right? Because I could easily take this box and like turn it on its side, right? I could rotate it. It's still gonna have the same measurements. It's just gonna be oriented in a slightly different way. So, you know, I said that the length was 10. I could have just as easily have called that the width. It doesn't really matter. You just want to make sure you're taking those three different measurements and multiplying them together. So 10 times 4 times 5. So 4 times 5 is 20. And 10 times 20 is 200. So the volume of this rectangular prism is 200 cubic inches. Now, you might sometimes see that abbreviated. Cubic is sometimes abbreviated as CU, so CU. And then we usually abbreviate inches as IN. And then sometimes you might also see it written as inches cubed, or inches to the power of 3. Most of the time, I'll be writing it that way just because it's the shortest way to write it. Okay, so we just found the volume of this rectangular prism. Now, what about if you know the volume, but you have a missing measurement? So let's try a problem like that. Switch colors here to show that we're talking about a different type of problem. So let's say a rectangular prism has a volume of 400 cubic inches. And let's say the length is 10 inches. And the width is 2 inches. Find the height of this shape. So we're talking about a rectangular prism and we're given the volume. So I'm going to start the same way. I'm going to start with the formula. Volume is equal to length times width times height. Now I'm going to fill in the information that I know. So I know the volume is 400 cubic inches. I know that the length is 10 inches. And I know that the height, the width is 2 inches. The height is unknown. I don't know what the height is. So I need to solve for the height. I need to figure out what the height is. Well, First thing I can do here is I can simplify the right side of my equation a little bit. I can go ahead and I can do that multiplication 10 times 2, right? It's saying 10 times 2 times the height. So I can go ahead and do 10 times 2. So I'm going to have 400 is equal to 20 times the height. So we're looking for a number that when we multiply it with 20, we get 400. That number might jump out at you, but if you're not sure, what calculation would you do to help you figure it out? Well, we should divide, right? We should do the opposite. If 20 times h is 400, then h is going to be 400 divided by 20. Another way we can think about it is we want to cancel out that 20 from the h, from the side that has the h, right? We want to just know what h is equal to. We don't want to know what 20h is equal to. So we do the opposite of multiplying. We divide by 20. Same thing to both sides. This is going back to our unit where we practiced solving equations. This is an application of that skill that we practiced. And so we will be left with h is equal to 20. So for this particular rectangular prism, has a volume of 400, a length of 10, and a width of 2. The height must be 20. 20 inches, that is. So the height of this prism is 20 inches. Okay. So the next thing we're going to do here is we're going to practice finding the surface area of a rectangular prism. So take a look at your formula sheet and find the formula for surface area of a rectangular prism. So you should see that the surface area is equal to 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. Now, where does all that come from? Well, remember what surface area means. Surface area means you're finding the area of each face, of each flat surface of the shape, and then adding them all up together. So for a rectangular prism, we've got 6 rectangles, but they come in pairs, right? So if you have a box, the top and the bottom are going to be the same size. The front and the back are going to be the same size, and the left and the right sides are going to be the same size. That's where we get these 2's from in our formula. So it's saying we've got 2 rectangles where we'll get the area if we do the length times the width. So on this box that we have on the screen here, that would be the bottom of the box and the top of the box. So both of those we would do length times width for. And then 2 of the rectangles will be length times height. So that would be this side here and this side here would be the length times the height. And then 2 of the rectangles are going to be the width times the height. So that would be like, from our perspective, like the front of this box and the back of this box are going to have those measurements. So let's go ahead and calculate the surface area of this rectangular prism. So it's going to be 2 times 10 times 4 plus 2 times 10 times 5 plus 2 times 4 times 5. So we just got some multiplication and adding to do. I'm going to follow the order of operations. I'm going to do all of my multiplying first and then do my adding. So 2 times 10 times 4. 10 times 4 is 40, times 2 is 80. 10 times 5 is 50, times 2 is 100. And 4 times 5 is 20, times 2 is 40. So I just did all my multiplication. Now I can add up these numbers. So 80 plus 100 plus 40. So we get 180 plus another 40 is going to give us 220. So this rectangular prism has a surface area of 220 square inches, right? We're talking area here. So this is square inches. All right, now let's take a look at right prisms. So a couple of slides ago, we talked about the fact that right prism is a more general category. So there are lots of different types of right prisms out there. A rectangular prism is a type of right prism. Here on the screen, I'm showing you a triangular right prism, right? So either end, either of those flat ends are triangles. You could have a right prism where either end is a square or a trapezoid or a parallelogram or a star. You could get real crazy. So this particular right prism, either end is a triangle. So let's start by talking about volume. We take a look at the formula for volume of a right prism. It says volume is equal to capital B times H. Now, what does capital B stand for? Well, it does actually say on your formula sheet. Capital B stands for the area of the base. The area of the base. So whatever your whatever shape your base is, in this case, the bases are triangles. Capital B stands for the area of that shape. So we would, if we want to find the area of these triangles, we're going to have to use the formula for area of a triangle. So let me start out by giving you some measurements here. Let's see. Let's say this is 8. And say we have 10 and 10. And let's do feet here. And then this h sub a, this height, let's call it 3 feet. And then the height of the prism, let's call it 20 feet. Okay. So if we want to calculate the volume of this triangular right prism, we're going to need to find the area of the base, the area of one of these triangles. So for that, I'm going to use the formula for area of a triangle, which if we take a look at our formula sheet is half the base of the triangle times the height of the triangle. So if you look at this triangle and you sort of ignore the rest of the shape, so I've told you that this here is 8 feet. This side is 10 feet. This side is 10 feet. And then this is 3 feet. So anytime we're talking about base and height of a shape, the base and height always make a right angle with each other. They're always perpendicular. That's what's indicated by this little sort of square symbol where these two lines meet. It's showing that they're meeting at a right angle. So that tells me that that dotted line through the middle of the triangle represents the height. And then A, side A at the bottom there, is the base of the triangle. So the area of this triangle is going to be half of 8 feet times 3 feet. So 8 feet times 3 feet gives us 24 square feet. but we want half of that. So half of 24 is going to give us 12 square feet. So the area of that triangle is 12 square feet. Now we're ready to go ahead and calculate the volume of this entire prism. So the volume will be the area of the base times the height of the prism. So that's the 20 feet. The height is always the length of the tube that's connecting the two shapes sitting at either end. So it doesn't matter if the, this prism is kind of standing upright, even if we like knocked it over so it was laying along its side, that height is still the height. It's basically the length of the tube that's connecting the two shapes at either end. All right, so we have 12 square feet times 20 feet. So altogether, the volume of our right prism is 240 cubic feet. 240 cubic feet. Now, how is this related to the rectangular prism that we just calculated the volume of? Well, keep in mind this formula here. Volume equals area of the base times the height. Well, let's take a look back at this formula. It's saying volume equals length times width. Well, what's the formula for area of a rectangle? So the area of a rectangle is the length times the width, this right here. So this is the area of one of the bases times the height. This formula is following that more general formula where the volume of a right prism is the area of the base times the height. Right, so with the triangle, the volume was half the base of the triangle times the height of the triangle times the height of the prism, right? For the rectangular prism, the volume was the length times the width times the height. But they're all just types of prisms. Okay, so next let's calculate the surface area of this prism. So surface area of a right prism, the formula that we see on our formula sheet is SA, surface area is PH plus 2 capital B. So here's one more new letter that we haven't encountered before with our formulas. We have this lowercase p. So lowercase p stands for the perimeter of the base. So capital B is the area of the base. Lowercase p is the perimeter of the base. So in order to calculate the surface area of a right prism, we need to calculate the perimeter of the base. So in this case, it would be the perimeter of one of the triangles. And then times the height of the prism plus 2 times the area of the base. So we need to know the area of the base also. So perimeter of the base, height of the prism, and area of the base. So for this right prism, for this triangular right prism, let's first figure out the perimeter of the base. So let's look at our triangle, right? We want to remember that perimeter is the distance all the way around the outside of the shape. So if you're just looking at the triangle, ignoring the rest of the prism, then the perimeter is going to be adding up the 3 sides, right? So 8 feet plus 10 feet plus 10 feet. 8 plus 20 gives us 28 feet. So all the way around that triangle is 28 feet. And what about the height? We know that the height of the prism is 20 feet, right? That's labeled on our shape. And the area of the base, we also know, we calculated that before when we did volume. The area of the base is 12 square feet. So we're ready now to calculate the surface area. The perimeter is 28 feet. The height is 20 plus 2 times the area of the base. So again, we just have some multiplying and adding to do. So 28 times 20 is 560. So that's going to be 560 square feet. So that part of the formula, the perimeter of the base times the height, that basically is describing the surface area of the tube. So the part that's kind of going around like this. And then the 2 times the area of the base is talking about the areas of the 2 bases. So in this case, the triangle on top and the triangle on the bottom, they're the same. And that's why it's 2 times the area of the base. So here it's going to be plus 24 square feet. And 560 plus 24 is 584 square feet. So the surface area of this triangular right prism is 584 square feet. Okay. Now let's talk about pyramids. We'll start with, well, first I'm gonna put some measurements onto this pyramid here. So I'll call this the length of one of these sides. And it's, let's say it's also 8 yards, let's say. And this slant height here, I'll call it S. It's going to be, let's say 15. And, oh, I changed my mind. Let's call this 20 yards. Call that 20 yards. And then we're going to have this line going up through the center. Let's call that 12 yards. Okay, so with a pyramid, with a square pyramid, there's a few measurements that we will need to concern ourselves with when we're talking about volume and surface area. So the first one is about the measurement of the base, or that square that's at the bottom of the pyramid. So we need to know the length of the sides of that square. So here I have it labeled for you. I'm telling you that the square is 20 yards on each side. We're also going to need to work with the height of the pyramid. So height is a line that's perpendicular to the base, right? In this case, it's just going straight through the center of that pyramid down to the base. So this pyramid is 12 yards tall. And then we're also going to be using the slant height. So the slant height goes up the side. It's that diagonal measurement going up the side of the pyramid. It's like if you were to walk up the side of this pyramid, you would be walking 15 yards. So those are the measurements we're going to need to use. Let's start with volume. We'll practice calculating volume. The formula says that the volume of a pyramid is 1/3 the area of the base times the height. So one thing you might start to notice as we go through all these formulas is we start to see kind of the same things showing up over and over again. A lot of these formulas are built off of each other or very closely related to each other, right? So when we were just talking about a right prism, we saw that the formula for volume was the area of the base times the height. So we're basically saying that a pyramid is 1/3 of a prism. You could kind of imagine like a square pyramid. You could imagine it sitting inside of a box. right? And filling up part of a box, but it wouldn't fill up the whole thing. So a square pyramid, we can think of it as being like a third of a rectangular prism. So for this particular square pyramid, let's go ahead and calculate the area of the base first. So what kind of a shape is the base? The base is a square. How do you calculate the area of a square? Well, we can think of a square as just a type of rectangle, right? And the area of a rectangle is length times width. So we're going to do the length times the width, but with a square, the length and the width are the same thing, right? All four sides are the same. So I am just going to do 20 yards times 20 yards. And 20 times 20 is 400 square yards. So that's the area of my base. Now I'm ready to calculate my volume. So it's a third the area of the base times the height. So I'm going to go ahead and let's do that multiplication. So 400 times 12 is going to give us 4,800. So we're looking for a third of 4,800 cubic yards. Well, how do we find a third of something? Well, think about this. How would you find a half of something? Like, let's say we wanted to know what's half of 20. Well, half of 20 is 10, right? What you just did is you took 20 and you divided it by 2. So a quick way to find a half of something is to divide it by 2. We can apply that to any fraction in general where the numerator, the number on top is 1. So like 1/2 or 1/3 or 1/4. We just divide by the denominator. So to find a half, you divide by 2. To find a third of something, you divide by 3. So 4,800 divided by 3. Well, you could think of it as 48 divided by 3. 48 divided by 3 is 16. So 4,800 divided by 3 is going to be 1,600 square cubic, sorry, 40. I have an extra 0 here. Sorry about that. I said 4,800, but I wrote 48,000. So I meant 4,800. I'm just going to scribble out that 0 there. So a third of 4,800 is 1,600. So our volume is 1,600 cubic yards. Now, if we go back to where we were right here, this is actually a multiplication, right? We're saying a third times 400 times 12. So you can actually do that multiplication in whatever order is convenient to you. The order of multiplication doesn't matter. So we just did 400 times 12 first. But if you wanted to, you could do a third times 12 first. So a third times 12, that's a third of 12. 12 divided by 3, which is 4. So what would 400 times 4 be? 400 times 4 would be 1,600. So we get the same answer. You can do it in whichever order is convenient to you, whichever order makes the calculations simplest for you. Okay, so that is the volume of this square pyramid. Let's go ahead and find the surface area. So surface area, take a look at your formula sheet. The surface area of a square pyramid is half of the perimeter of the base times S plus the area of the base. So here we have the last new letter for our geometry formulas, this lowercase s. So this lowercase s is standing for the slant height. you'll see this letter pop up in the formula for a pyramid here. You'll also see it in the formula for surface area of a cone. So that shows up in both places. It's the slant height. It is not the same thing as what you see up at the top of your formula sheet for area of a square. If you look where it says area of a square, it says A equals S to the power of 2. There they are using S to stand for side length. That's not great mathematical practice in general. If you're talking about two different things on the same piece of paper, you should use two different letters to stand for the two different things. So it can get a little confusing, but for these three-dimensional shapes, when we're talking about surface area, that S stands for slant height. So it's what you see on the picture here. The slant height is that slanted height, so going up the side of this three-dimensional shape. Okay, all of those other letters we already know, right? P stands for perimeter of the base and capital B stands for area of the base. So we've already calculated the area of the base of this square pyramid. It's 400 square yards. But we haven't calculated the perimeter of the base yet. So let's do that. Let's figure out P before we get ahead of ourselves. So the perimeter of this base, it's a square. So adding up all of the sides of our square, well, it's 20 plus 20 plus 20 plus 20, right? All four sides added together. You could think of it as addition, or you could take a little shortcut and think of it as 4 times 20. I'm going to do it that way. So 4 times 20 yards gives us 80 yards. So it's 80 yards all the way around the bottom, the base of this pyramid. Okay, and then we know that the slant height, right, it's labeled for us, it is 15 yards. So we are ready to calculate our surface area. So it's half of the perimeter times the slant height plus the area of the base, which is 400 square yards. Okay, so I'm going to go ahead and do my multiplication. We have half of 80 times 15. It's going to be convenient for me to take half of 80. Half of 80 is 40. And then I would do 40 times 15. So 40 times 15 gives me 600. So that'll be 600 square yards plus 400 square yards. So altogether, my surface area is 1,000 square yards. So if you were going to cover this pyramid with wallpaper, you would need 1,000 square yards of wallpaper. All right, so now we're going to move on to our shapes that involve circles. We're going to start with a cylinder. If you take a look at the formulas for cylinders, cones, and spheres, right, those all involve circles. So you'll notice they are all using pi, right, that Greek letter pi that we talked about in Unit 12. And they're also using the radius of the circles. So we want to remember that radius of a circle is the measurement going from the center to the edge. That's the radius. That's a little bit different from the diameter. The diameter is the measurement going all the way across through the middle of the circle. So if you know the diameter, it's pretty easy for you to determine the radius of the circle. All right, let me give you some measurements for this cylinder on the screen here. Let's say the radius is 3 meters. And let's say the height is 10 meters. So let's start with volume. The formula for volume of a cylinder. Let's check our formula sheets. It says the volume is pi r squared So pi times the radius squared times the height of the cylinder. So we know that pi is approximately 3.14, right? Pi is this special number that we use when we are working with circles. It is, it describes the relationship between the circumference of a circle and its diameter, but just so happens that it is always the same number. So it is always approximately 3.14. So when you're doing your calculations on the GED test, you should always use 3.14 for pi, unless the problem specifically tells you to do something else. So for this cylinder, pi is 3.14 times the radius squared, so 3 meters squared, times the height, which is 10 meters. Okay, so I'm going to go ahead and just take care of that squaring, that exponent. 3.14 times 3 meters squared. What is 3 meters squared? Well, it means 3 meters times 3 meters. So that's going to be 9 square meters times 10 meters. So I'm going to use my calculator now. 3.14 times 9 times 10. So that gives me 282.6 cubic meters, because we're talking about volume here. So cubic meters. Okay. Now let's actually get some practice with a type of problem where we have to solve for the missing measurement. So let's actually take the same cylinder. So let's say the volume of a cylinder is 282.6 cubic meters. And let's say the height of the cylinder is 10 meters. Solve for the radius. Okay. So we are pretending that we don't know the radius of this cylinder. So we're talking about volume of a cylinder. We're going to start with our formula. Volume equals pi times the radius squared times the height. I'm going to fill in the information I know. I know the volume is 282.6. I know that pi is 3.14. I'm going to bring my height out to the front here before the radius, just because in general, when you have an unknown variable mixed in with multiplication, you typically put the numbers you know up front in the multiplication and the unknown number at the end. So I'm going to put my height here. The height is 10. And my radius squared, I don't know what that is yet. So same thing as before. We're going to go ahead and do the multiplication we can do. So 3.14 times 10 is going to give us 31.4. So we know that 282.6 is equal to 31.4 times the radius squared. So how are we going to get the radius squared by itself? Right? How are we going to cancel out that 31.4? We're going to do it by dividing. So our radius squared is going to be equal to 282.6 divided by 31.4. Let's get out our calculators. 31.4. All right, so we get that the radius squared is equal to 9. Now, I don't want to know what the radius squared is. I want to know what the radius is. So how do you cancel out or kind of peel back an exponent of 2? How could we get rid of that squared and just be left with r? Well, the way that we do that is by taking the square root, right? All operations have an opposite, right? So dividing is the opposite of multiplying. Subtracting is the opposite of adding, and vice versa. So if you have r to the power of 2, r squared, to undo that, to kind of peel that away, we would take the square root. We would do the opposite. So if I square root both sides here, I'll be left with r is equal to the square root of 9. You could do that on your calculator, but you shouldn't need to. So the square root of 9, what number times itself equals 9? 3. So the radius of the cylinder must be 3. And that's good because we actually already knew that. Right? We knew that the radius of the cylinder was 3 from the beginning. Okay. So another example of kind of a solving problem where you are told the volume, you're given some of the measurements, but you have to solve for a missing measurement on a shape. All right, now last thing we will do here, let's talk about surface area. I'll just do that over on the side here. So surface area of a cylinder. Take a look at your formula sheet. Surface area is 2 pi times the radius times the height plus 2 times pi r squared. And we know all these measurements, right? So our radius is 3, our height is 10. We know that pi is approximately 3.14. So I'm going to plug in my numbers and then do my calculation. So 2 times 3.14 times the radius of 3 meters times the height of 10 meters plus 2 times 3.14 times the radius of 3 meters squared. So 3 squared. Okay, so 2 times 3.14 times 30 gives us 188.4. That's going to be square meters. Plus 2 times 3.14 times 3 squared. What is 3 squared? 3 squared is 9, right? 3 times 3 is 9. So that gives me 56.52 meters squared. And when I add those together, I get 244.92 square meters is the surface area of my cylinder. So in general, when you are working on a geometry problem, first thing you need to do is you need to identify what kind of a shape are you working with. So we look at this page, we see, we're working with a cylinder. And then you need to know what kind of measurement are you talking about? So is the problem talking about volume? Do you need to calculate surface area, right? What's going on? Once you know that, then you can go to your formula sheet and you can copy down the formula that they give you. And because you've practiced along with this lesson and done your homework, you will look at that formula and be able to follow the instructions that the formula is giving you. Okay. Next, let's talk about cones. And let me give you some measurements for this cone. So let's say this is 3 inches, 4 inches, and then we'll call this 5 inches. Okay, so with a cone, there are, if you take a look at the formulas for surface area and volume, you will see things that we're already familiar with. So radius, we're going to be using the height of the cone. We also have S for slant height, right? So the height is going straight down the middle of our cone from the base up to the point at the top. The slant height is going up along the side of the cone. And then the radius of this cone is 3 inches. What would the diameter of this circle be? So if the radius of the circle is 3 inches, what would the diameter be? So the diameter would be 6 inches, right? 6 inches going all the way across. All right, so let's start with volume. The volume of a cone is 1/3 of pi r squared times the height. So this should be looking kind of familiar. It's related to a couple of things here. First thing we might notice is that the formula for area of a circle is hiding inside of this formula, pi r squared, right? So that's the area of the circle at the base of the cone. So we could think of this as 1/3 of the area of the base times the height, right? It's basically 1/3 of a cylinder. It's 1/3 of a circular prism. You could think of it like that. Okay, so we know all of those measurements that we need. We know that pi is 3.14. We know that the radius is 3 inches and the height is 4 inches. So let's try something a little bit different on this problem. So sometimes on the GED test, you might encounter problems on the non-calculator section where they're not wanting you to kind of fuss around with multiplying with decimals, doing a lot of fancy calculations. They are just wanting you to focus on the concepts. So with geometry problems involving circles, they'll often have you just write your answer in terms of pi. So it basically means you do all of your calculations up until multiplying by 3.14. You don't do that step, you just leave pi alone. So let's see what that looks like here. Let's say I just think of this as pi. I don't bother with the 3.14. So I'm gonna do this calculation in terms of pi. I'm gonna leave pi there. So I've got 3 inches squared. That is gonna be 9 square inches times 4 inches. And I've also got this 1/3 out front here. I'm actually gonna go ahead and do that 1/3. Remember, this is all multiplication, 1/3 times pi times 9 times 4. So I can do the multiplication in whatever order is convenient to me. Multiplying by 1/3 is just like dividing by 3. So I'm actually gonna take 1/3 of 9 because that's gonna be a simple mental math calculation for me. 1/3 of 9 is 3. So I'll leave that pi out front. We've got, this will become 3 square inches times 4 inches. So that'll give us pi times 12. And then typically if you have a letter or a variable sitting there that's not an actual number, multiplied by an actual number, we put the actual number out front. So I would rewrite this as 12 pi cubic inches for my final answer. So this is the volume written in terms of pi, right? I haven't taken that final step of actually multiplying the 12 by the 3.14 because that would be a slightly more involved calculation. I'd probably want to take out my calculator for it to make it a little quicker. So again, this is something that you might see show up on the first part of the GED math test where you are not using your calculator. But let's say this is in the second part and we do actually want to get a more precise answer. we could go ahead and multiply. So 12 times 3.14, that would give us 37.68 cubic inches. So just a little example of different types of ways that these questions could be asked on the test. Okay, and next, let's talk about surface area. Take a look at your formula sheet. Write down the formula for surface area of a cone. It says that the surface area is pi times the radius times the slant height plus pi r squared. So plus the area of the base, right? The area of the circle at the bottom. So we know all of those measurements. I'm going to go ahead and just get right into my calculations. Let's do the same thing we did before, where we try to just calculate the surface area in terms of pi. So we're going to leave the pi's alone and just do everything else. So pi times the radius times the slant height plus pi times the radius squared. So pi times 3 times 5. I can do 3 times 5. That's going to be 15, pi times 15. I'll write that in the more usual way. I'll write it as 15 pi. So pi times 3 times 5, I just turn that into 15 pi. And then for that second term there, pi times 3 squared, well, 3 squared is 9. So this becomes 9 pi. So we have 15 pi's plus 9 pi's all together. That is 24 pi's, 24 pi. So that would be 24 pi square inches because it's surface area that we're talking about here. And now let's say this isn't the first non-calculator section of the GED. Let's say that we're on the second section where we're being asked to use our calculator to actually multiply with decimal numbers. So 24 times 3.14 equals 75.36 square inches. So again, just an example of a couple of different ways that you could be asked to format your answer on this type of question. All right, now on to our last shape. Our last shape that shows up on the formula sheet is spheres. So this is like a ball or a globe shape. And the most important measurement we're going to be using here is the radius. So going from the center of the sphere out to the edge of the sphere. Let's say the radius of this shape is, I don't know, let's do 7 feet. 7 feet. Okay, so start with volume. Formula for volume of a sphere, it says 4/3 pi r cubed, not pi r squared, pi r cubed. I want to be careful about that. Okay, so we know the radius of the sphere. We could go ahead and we can calculate the volume. And let's treat pi just right away as 3.14. Okay, so here, instead of 1/3, we have 4/3. So we can still think of taking 1/3 as dividing by 3. But then you have that 4 there. So that's like multiplying by 4. So we're multiplying by 4 and we're dividing by 3. That's essentially what doing 4/3 of something is. So 4/3 times all of that stuff. We're going to multiply everything by 4 and we're going to divide by 3. So first, let's do the cubing there. So 7 to the power of 3. It's a big-ish number, 343, right? That's 7 times 7 times 7. So I get 4/3 times 3.14 times 343 cubic feet. Okay, now I'm going to multiply by 3.14. That gives me 1,077.02. And then I've got my 4/3 out front there, which I didn't really give myself enough room for, but we still got the 4/3 out front. Okay, and then 4/3 times 1077.02. I'm gonna multiply it by 4 and then divide by 3. So I get something with a repeating decimal at the end. So I'm gonna have to round this, but I'm getting 1436, 1,436.0266666. It's repeating, the 6 is at the end there. And that is cubic feet that we're talking about. So let's round this to the nearest whole cubic foot. Rounded to the nearest whole cubic foot, write the nearest whole number. This would become 1436, 1,436 cubic feet. So before we talked about what to do when you're taking 1/3 of something, it's basically just dividing by 3. If you're doing 4/3, that's like multiplying by 4 and dividing by 3. And then finally, let's do surface area of a sphere, our last geometry formula. So this is actually a relatively simple formula, I think, compared to the other ones we've seen. So the surface area of a sphere is 4 times pi times the radius squared. So for this particular sphere, it's going to be 4 times 3.14 times 7 feet squared. 7 feet squared is going to be 49, right? 7 times 7 is 49. So 4 times 3.14 times 49 square feet. And when I do that multiplication, 4 times 3.14 times 49, I get 615.44 square feet. Talking area here, so 615.44 square feet. So if you were trying to cover this sphere in wrapping paper, you would need 615.44 square feet of wrapping paper. All right, so those are all of our geometry formulas. Again, the formulas are just little shorthand instructions for how to find these various measurements. And you can use them for all of the geometry formulas that you're presented with on the GED math test. Okay, so we're going to finish things up today with a few word problems. So these are similar to the types of problems that you might see on the GED math test. So number 1, a rectangular box with a length and width of 4 feet has a volume of 80 cubic feet. What is the height of the box? So I've got a box here for you to help you think about it. But if you have a box sitting next to you, you could take that out and look at it to help you think through this. So it has a length and width of 4 feet. So I'm going to go ahead and label that here. The length is 4 feet. The width is 4 feet. We are being asked to find the height of the box. We don't know how tall it is, what the height is. We do know the volume though. So this problem is talking about volume of a rectangular box. So what formula should we be thinking about? Well, it should be a formula for volume of a rectangular prism. So the volume is length times width times height. So we have our formula. We know what we need to solve for, right? The missing piece is the H. I'm going to fill in all the info that we do know. So the volume is 80 cubic feet. The length is 4 feet. The width is 4 feet, and we are missing the heights. So we can go ahead and do 4 times 4. That's 16. So 16 times some number equals 80. Now you might know that off the top of your head. It might jump out at you, but let's say you're not sure. That means we need to solve for the H. We need to get the H by itself by canceling out the multiplication. So we do the opposite of multiplying. We divide. Divide both sides by 16. And so we are going to be left with our height is equal to 5. So the height of the box is 5 feet. 5 feet. And you can always go back up to your original formula and double check that you get the correct volume. So if we're saying the volume is the length times the width times the height, then we should be able to do 4 times 4 times 5. And that should give us our volume of 80. So we can go ahead and do that. 4 times 4 times 5 does give us 80. So that's a way to double check that your answer makes sense. Okay, let's try another one here. The height of a cone is half the diameter of its base. If the cone's height is 4 inches, what is the cone's volume to the nearest cubic inch? Okay. So we're talking about a cone here, and I see the question is asking me about volume. So I'm going to go ahead and write down the formula for volume of a cone. The volume is 1/3 pi r squared h. So we need to know the radius of the base, right? The radius of the circle at the bottom of the cone. And we need to know the height. Do we know those measurements? Well, we know the height. It says that the height is 4 inches. What about the radius? Well, it looks like they're giving us information about the diameter. So we're probably going to have to figure out what the diameter is and then use that to figure out what the radius is, because we know that diameter and radius are really closely related. So the height is half the diameter. The height is half the diameter. So if the height is 4 inches, that is half of what? So 4 is half of what number? 4 is half of 8. So that means that this circle all the way across, right, the diameter is 8 inches. So if all the way across is 8 inches, if the diameter of the base is 8 inches, what is the distance from the center to the edge? So basically halfway across the diameter. It's going to be 4. So the radius of this circle, the radius of the base of this cone is 4 inches. So the volume is 1/3 times 3.14 times 4 inches squared times the height, which is 4 inches. Okay. So 4 inches squared, that's going to be 16. Let's just go ahead and make sure we're following our order of operations, get that exponent done. All right, so now I'm going to do 3.14 times 16 times 4. I'm getting 200.96, so 1/3 of 200.96. It's going to be cubic inches. And a third of that, I'm dividing by 3, gives me 66.98. And then we're getting repeating 6s at the end here, cubic inches. So let's go ahead, let's round that. Let's round it to the nearest whole cubic inch. Well, that's actually what it says in the question, rounded to the nearest cubic inch. So rounded to the nearest cubic inch, it's 66.9. So that will round up to 67 cubic inches. So we look at this problem, we see it is talking about volume of a cone. So we wrote down our formula for volume of a cone, and we thought about what measurements we need to plug in there to calculate the volume. We needed the radius and we needed the height. The problem told us the height right away. And it didn't tell us the radius, but it gave us information we used to figure out the radius, right? So it described the diameter in terms of the height. The height was half the diameter. So if the height was 4, 4 is half of 8, the diameter was 8. And then if the diameter is 8, that means the radius of the circle is 4. So we were able to plug in the measurements for radius and height and then just do our calculations with the help of our trusty calculator. Of course, you could do all of this without a calculator. The calculator is just there to speed things along so that you are not spending lots of time doing calculations by hand. Okay, and then the last word problem we're going to do today says all edges of a metal box are of equal length. So a box where all of the edges are of equal length. That sounds like what type of shape? Well, if it's a box, that means we're talking about a rectangular prism, but specifically what kind of rectangular prism? If everything is equal, all of the edges are the same. It means we're talking about a cube, a little cubic metal box. So something that looks kind of like this. So maybe it's something that's sitting on your desk holding some pens or something like that, or maybe a little tiny lock box that you have. So it says if the surface area is 150 square inches, what is the length in inches of each edge of the box? Okay, so let's think about this here. We want to remember that, so we're talking about surface area of a rectangular prism, essentially. Now we could think about the formula for surface area of a rectangular prism. Now you might look at this and you'd be like, how am I possibly going to use this to solve for length? Well, it's going to become a lot simpler when we actually remember that a cube is special because instead of having like 6 different rectangles, we actually have just 6 squares that are all the same. So how do you find the area of a square? We actually don't even really need to think too much about this formula. How do you find the area of a square? Well, you do the length times the width, or you could think of it as like the side times the side length times the side length. So if we can figure out and that's actually what we're trying to figure out, right? We're trying to figure out the length of one of the edges of this cube. So the surface area is going to be adding up the areas of all 6 of these identical squares. So it's 6 identical areas. We could think of it as 6 times the area of one of these squares The area of one of the squares is the length times the length, or the length squared. So 6 times the length squared. Now I'm using L here instead of S because, like I mentioned before, I don't like that they use S for side length when they're talking about squares, but then they use S for slant height when they're talking about pyramids and cones on the formula sheet. It's very confusing. I don't like that. So we're using L for length of one of these sides. So the area of one of the squares is going to be the side length times the side length, or the side length squared. And we have 6 of those squares that make up this box. So the surface area will be 6 times the side length squared. So they tell us the surface area. We know what the surface area is. It is 150 square inches. So I'm going to replace surface area with 150. So 150 is equal to 6 times something squared. We want to end up with that missing number, that variable by itself. So we need to cancel out that 6. We cancel out that 6 with division, right? The 6 is being multiplied with L squared. So we do the opposite, we divide. Both sides by 6, dividing both sides by 6. So we find that L squared is equal to 150 divided by 6, which is 25. Now, I don't want to know what L squared is. I want to know what L is. So what's the last step here? How do we get rid of that squared? How do we get rid of that exponent of 2? We already did something kind of similar to this earlier in the lesson. To cancel out the exponent of 2, we take the square root. We'll do the same thing to both sides. So we end up with L is equal to the square root of 25. What's the square root of 25? It's 5, right? 5 times 5 is 25. So the side length, or the length of each edge of this box, is 5 inches. It is 5 inches on each side. All right, everybody. Well, thank you so much for joining me for this lesson today. I know there's a lot of information, a lot of formulas there, so I appreciate your patience and your perseverance for making it to the end. I hope you find this helpful as you're working on your homework. Don't forget to check out the extra videos for this unit that I've posted on the Google Classroom, and I'm sure I will be talking to all of you very soon. Take care.